Hello, everybody. We'll wait for 5 more minutes and then we'll start the session.
Yes, sir.
Sorry. Okay. Um, so we'll start for this week's assignment. So this week, I guess in NPTEL, what was covered is DC speed control, and then H bridge. Using H bridge, you have made the driver for a DC motor, and you use PWM signal to control your H bridge, right? So this is what was taught this week, and for the assignment or the quiz, these are the type of problems for the quiz. Right. So we'll take one example question. This is one. So we'll find different things from one single problem. So this will mostly cover what is there in your assignment. Yeah. So apart from that, I'll be taking questions if anyone has one. Okay. So first we'll get started. Um, like um, okay, let me just explain the theory. A DC motor can be of two types, that is permanent magnet DC motor and wound field DC motor. So what is the difference between them? Your DC motor, the PMDC motor, PMDC has a magnet, that is your north and south. Um, Actually, they are dipole. South. Okay. So here is your rotor. This arrangement can be reversed. You may have a motor with a magnet as the rotor, and this can be coils, right? So both of them will constitute to permanent magnet DC motor. The other kind of it is wheeled, sorry, wound field DC motor, where you can have your you will be having both uh, your stator with coils that you can control, right, and your rotor will also have coils, or it will be a soft core. So let me admit few people. Yeah. So here, um, so the actual difference in, let's take in the problem that we are dealing with here, the B that you have is constant, right? For such type of motors, B is constant. You cannot alter the field. Here you can control B, either by voltage control or current control. Either of them. We'll generally use voltage control, right? So we'll be dealing with these kind of motors to solve such problems, right? So let me just copy this question. Oops. Yeah. So now let us take that we are interested in finding armature armature voltage, right? So we would directly use the um, speed torque relation here equation. Why are we using this equation is that look at the given. We have the speed at which the motor is being operated, and apart from that we have given a torque equation that is with respect to omega, right? The torque of the from the inductor is a function of omega. This is omega, not w, 0.002 omega square. So from this given, we understand that um, um, we need to use speed torque equation so that we find the unknown. Let us take the first problem is finding armature voltage. Here speed torque equation is omega will be V armature divided by K minus uh, the resistance of the armature coil times the current that is flowing. That is nothing but Ti, the load torque divided by K square. Actually, if you see this equation, where it comes from is your EMF, back EMF, plus, yeah, the voltage drop across the armature, that will be equal to your voltage armature. The voltage drop across um, the armature winding is this one, and this is the voltage drop across it. So if I have to put it in a diagram, it will look something like this. Yeah. So this is the back EMF, because while operation, the field will the armature will be cutting the field while it is rotating. So because of that, you will get a back EMF. So this is nothing but VA, right? So in some questions, this VA is referred as input voltage, but we'll keep it VA because we'll also deal with question where we have duty cycles. So effective voltage is applied across this because of a switching gate, right? So from this equation, um, we know that 60 is given. V armature is something that we need to calculate. K is given as 0.3 minus R A, that is 0.4 times Ti, that is 0.002 omega square 60 square divided by K square, um, zero point 0.3 times 0.3, 0.09, right? So from this we can find VA. So let me just multiply 0.3, 63, 18, VA minus 0.4 times 0.002 times 3600. divided by 0.3. Okay, so 18 VA minus 0.2 times minus 7.2 times 4 by 3. Yeah, 7.2 times 4, 8, 7, 428 divided by 3. Yeah, 27, 9 point, yeah, 6, right? So 18 plus 9.6. So that will be 27.6. This is your uh, the voltage across this, right? So this is your voltage armature. Sometimes it is referred to as input voltage. So let us take another type of problem. Let's take second type where duty ratio is given. So this is the volt voltage armature is 27.6 volt. Let us use this value. We know that duty ratio, I'm just taking it, duty ratio is 0.3. So that means that this duty ratio 0.3, this is normal duty ratio, not in terms of H bridge. Yeah, so yeah, let me not confuse. Duty ratio is 0.3 here. So that is nothing but VA by V input. In your lecture, this is referred to as VG. Okay, so let's just keep it that way. 0.3 time, which is equal to 27.6 divided by VG, and then VG will be 27.6 divided by 0.3. This is divisible by 3. Yeah, 27. No, right? Yeah. 9 into 3. Okay. 3.2. So VG is 32 volts. Okay. Yeah. So this is one type of problem. The third type, or a counterpart of second, is that input is given. You need to find duty ratio. This is fairly trivial, I think. Yeah. So there is another type of problem where you find ripple current, right? So this ripple current can be a ripple current slope, or yeah, or delta difference over the period of the time. Yeah. Okay. Yeah. So now, yeah. So now a circuit diagram will change a little bit. In such problems where ripple current is involved, we generally don't take the resistance, because in practical cases, these resistance are really small as compared to the voltage we are running. Yeah,
Excuse me, sir.
Abhijit.
Yeah, this VG is coming out to be 92 because 27.6 divided
Yeah,
by point
yeah.
0.3 is.
Sorry, I made a mistake. 92.
Okay.
Sorry.
Yeah, okay. Thank you, sir.
Yeah. Ripple current. So the circuit will look something like this. We'll have an inductor, that is nothing but our motor. We'll have back EMF, that is EB. We'll also have resistance. Let us just take it. So yeah. So here we'll use directly the relation from the inductor, and from that we'll get a slope current, that is L di by dt is equal to the voltage across this, right, um, minus EB minus RI, right? So di by dt will be Vg minus divided by L. Here, since we are taking Ri to be really small, R times I, sorry, IA, IA armature, right? Yeah, it's really less than Vg minus EB. So for a given omega, we know that back EMF will be constant. So this is nothing but your slope, right? If you need to find current, you'll have Vg minus EB by L, LA dt. You integrate this. Since this is a constant, it will be dependent on the time the circuit is active, right? T time, T on. Okay, so this is nothing but your current through the inductor for the T on time, right? So this is your ripple current. The fourth is finding duration. So many type of questions can be given here. One, IA is given. Based on that, you can find T on, right? IA is given. Based on that, you can find T on, right? So this is one type. The other is duty cycle is you have calculated duty cycle, duty ratio, right? From there, frequency is given, frequency of switching. The frequency, what it means is that this pulse of like T cycle, the total time of the cycle is dependent on the frequency. 1 by T cycle is nothing but your frequency. So to find T on, you would multiply duty ratio with T cycle, right? So based on that, you'll get T on. So these are the uh, problems that you'll have to calculate. Apart from that, there is conceptual questions also, that will be something like this, that you are given a H bridge. Let me make the diagram a little bridge, right? Right? So to make it a H bridge, we'll have four MOSFETs. So they are nothing but switches, right? And to stop um, back EMF, um, no, sparking at the switch or destroying your MOSFET, we would have diodes. So yeah, so you'd have S1, S2, S3, S4, right? Switching of S1 and S4 will result in positive terminal here and negative terminal here, and because of that motor will rotate in counterclock. Let us take this positive and negative, it will rotate clockwise, and the moment I operate S2 and S3, I'll be reversing the polarity of the motor, and because of that it will be rotating in the other direction. But the signal that we give to S2 and S3, like the duty cycle and everything we have calculated of the PW, based on that you can control the speed of the motor. So um, yeah, so uh, the question can be framed like this, that S2 and S3 is operated at certain frequency or duty cycle, duty ratio, and after that it is the same process that we have gone through, right? So this is how you need to do it, right? So yeah, this is pretty much this week's question. So now, if there is questions that you need to ask, we can answer that. Okay. I guess this week also it is fairly simple. Is there any doubt? So in cases where let's take your current across. So let us take this equation, VG minus EB minus VAIA divided by the inductance of the armature, right? In cases where RA cannot be neglected, I don't think you'll have a question on this. In cases where RA cannot be neglected, you know how to integrate this equation, right? So you will have this as a logarithmic relation. Okay, let's just make it B minus AI. Right? So this is of this form. Yeah. Okay. Here 1 by let us just put a C D, right? So integration of this, you will get ln B minus AI minus C, right? So from this you would get B minus E logarithm. I mean, you'll get exponential is C minus E power minus AC, and then you will have minus E, right? So this will turn out to be a graph like this. Let's take, you have started with some current, and then this will slowly rise and plateau. Yeah, minus, right? Yeah, something like this. So this is till T on duration. Okay, so this is pretty much for this week. I guess most of the questions will deal with speed torque equation. So sometimes you may have the speed to be equal to 0. This week you have this question. So from there you you can see that this both should be equal, right? So, any doubts? If there is no doubts, we can end the session, because this will cover all of it. You have any conceptual doubts? H bridge or something like that? No? Okay. Then let me stop the recording